Alright, today we're going to be looking at your chapter 20 worksheet number 2 on carboxylic acid homogeneous series. So let's take a look at chapter number 20 worksheet 2. Now you have learned about the other homogeneous series, so carboxylic acid as a homogeneous series will be the last group that you will need to learn. So general formula and the functional group of the carboxylic acid. For the general formula, carboxylic acids have this general formula CnH2n plus 1 COOH, and N starts with 0. So the first member will have an N equal to 0. Alright, so later you will sub it in and then you will find out what exactly is the molecular formula for the first member of the carboxylic acid. Now your carboxylic acid have the functional group of the COOH. So this is actually the functional group of carboxylic acid. All the members will have this functional group, and this is of course where all the reaction takes place. Okay, the COOH functional group. Now if I draw this out, this will be how the functional group actually looks like. Now, so let's take a look at the table. Question number 1, you're supposed to fill up the table. So I have filled up some of the information here for you already. Now the chemical name following the rest of the homogeneous series, right, is basically similar. Alright, how we name the chemical is similar to whatever you have learned before. So first part of the naming is depending on the number of carbon that is present in the molecule itself. So methanoic acid contains 1 carbon atom, ethanoic acid contains 2 carbon atom, so on and so forth. Then since it's a carboxylic acid, right, it will end with a ethanoic acid. So this is how you name it. Molecular formula, if you substitute using the general formula N equal to 0, you will get a molecular formula of HCOOH. So this is actually the first member of the carboxylic acid series. Alright, the rest of the physical property, like the boiling point and the physical state, I'm not going to talk too much. Basically, your carboxylic acid, they all exist as liquid at the room temperature. So exactly how does the structural formula of your carboxylic acid looks like? Let's take a look at the structural formula for methanoic acid. So this is how your methanoic acid looks like. You have the COOH functional group, and then of course you have your hydrogen over here. Now for ethanoic acid, right, same rule apply, similar to the rest. It's an addition of the CH2 group. So where will the CH2 group go? Now the CH2 group will actually come over here. Okay, so chemical formula CH3COOH. So this is your ethanoic acid. Just take note for your carboxylic acid, right, although you see there's only 1 carbon here, 2 carbon here, 3 carbon here, you will need to add the carbon in the functional group. Okay, so it's a total of 2 carbon atom. Now this is a structural formula for the remaining 2 other members of the carboxylic acid group that you all need to know. So please take some time to copy it down into your notes. Now moving on, let's take a look at question number 2. So what are some of the general formula for this carboxylic acid homogeneous series? Like what I've explained before, generally, if you're asked for the general properties, you can state the general formula. In this case, CnH2n plus 1 COOH. So all the carboxylic acid will have the same general formula. They have the same functional group, which is the COOH group. Compare this with the OH group for the alcohol and the carbon-carbon double covalent bond for the alkene groups. Alright, then this is actually similar for the rest. The difference, right, from each member to the next is actually just differ by the CH2 group, and carboxylic acid will show trend in the physical property as it becomes bigger in size, and they will all have similar chemical property due to the presence of the COOH functional group in all the molecules itself. So this is question number 2. Question number 3. Are carboxylic acid considered as acid? Why do we call them acid? Now this is because, right, your carboxylic acid, due to the presence of this COOH functional group, this hydrogen over here, what happens is that it will actually produce hydrogen ion in aqueous solution. So therefore your carboxylic acid are considered as acid. You do not know how that happens. Okay, that will be taught in JC if you decide to move on. Next, physical properties of acid, similar to whatever you have learned previously in Sec 3. As carboxylic acids are basically just acids, right? They will have sour taste, they have pH less than 7, and of course they turn your blue litmus paper red. Last but not least, they do dissolve in water to form solution which can conduct electricity as well. So think about why this is so. Take a look at 3A. They produce hydrogen ions, right? So when they dissolve in solution, I have hydrogen ions. Basically, I will have ions in the solution. These ions will be able to move freely to conduct electricity. Next, and more importantly, what are some of the chemical properties of your carboxylic acid? Now you'll notice that this chapter is actually a very short chapter, nothing much. Even for the chemical properties, right, basically what you're learning is very similar to whatever that you have learned before for acids, okay, and these are seldom tested in organic chemistry actually. So you just need to take note of some of the chemical properties of your carboxylic acid, like how they will react with reactive matter, just like your normal acid, to form salt and hydrogen. They will react with carbonate, hydrogen carbonate, to form salt, water, and carbon dioxide. And your acid react with bases like your insoluble metal oxide and metal hydroxide to form salt and water. And last but not least, the acids, right? Actually, carboxylic acid reacts with alcohol to form ester and water. Take note, this you will not be required to know what is ester, okay? This is actually not in the syllabus. Question number 4, and the last question for this worksheet. Now you're asked to suggest a pH range for your carboxylic acid. Now as an organic acid, this is actually a weak acid, so it will have a pH of about 5 to 6. Question 4b. Student accidentally mix up 2 bottles of colorless solution. One contains ethanoic acid and the other contains your hydrochloric acid. Provided with a few pieces of blue and red litmus paper, bottle of methyl orange, and a bottle of universal indicator. Describe how Key can make use of the given reagent to distinguish between the 2 bottles of colorless solution. So how can I differentiate and find out which one is ethanoic acid, which one is hydrochloric acid out of this few? Now if you think about it, first thing first, you need to understand that ethanoic acid, right, like what we have just explained previously, it is a weak acid, pH 5 to 6. Hydrochloric acid, on the other hand, is a strong acid, pH about 1 to 2. Will I be able to use litmus paper to differentiate between a strong and a weak acid? Now the answer is no. Litmus paper will only be allow us to differentiate between an acid and an alkaline. So red and blue litmus paper, basically this is out. We can't use this. Now what about methyl orange? Methyl orange similarly, right, will only provide a color change when a solution is in a range of a pH of an acid or if it's an alkaline. So that will not be able to help us to differentiate between a strong and a weak acid. So this is also out. Now this leaves us with your universal indicator, which actually will change color according to the pH of the solution that's present. So we will need to make use of the universal indicator to help us to differentiate between the ethanoic acid and your hydrochloric acid. So let's take a look at how we can describe and answer this question. So first step first, we describe how to make use of the universal indicator. Please do not just say use the universal indicator. I want to know how, so you gotta describe it. So very simply, just add a few drops of universal indicator into the acid. both acid if you want to be even more specific. And if the green color universal indicator turns red, then your hydrochloric acid is present in the solution because it is a strong acid. If the green universal indicator turns yellow or orange, then I will say that it is a ethanoic acid because it's a weak acid. So I've come to the end of the worksheet. Please fill out the worksheet